conexión formalmente. Formalidad ya de montar.
Hello, everyone. Sorry for being late.
Hi.
We had a little bit of a situation in our CBD.
Hi.
Hello.
Hello. So, yep.
Hello, everyone.
Hello.
Hello.
Hello, Christian.
Hi.
So, I'm not sure if we have to wait someone else. Do you know, Christina, if Moises should join or should
Yeah.
we? Ah, sorry.
Yeah.
It's your Mr. Enrib. Okay.
Yeah.
At hotmail.com. Sorry.
It's hidden, but it's here.
So I think everyone is here, and I guess we should start because we are constrained to a 1 hour slot normally. Today I guess that we have two topics, two main topics. The first is some questions related to BGP Flowspec from Carmen. Am I right, Carmen?
Yes, because this is needed for the new counters that Saba did for the Layer 2 bridge.
Okay, and and Christina, I presume that that you would like to have a quick discussion also about multicast Polka.
Yes, it will be great.
And if we have time, maybe I'm not sure if Moises wanted to talk about a specific topic, and I'm not sure if Everson will have to show us also related to multicast Polka. So, without further ado, I propose to. Oh, sorry.
I think it's called Multipath POLKA.
Ah, sorry.
But I also find it confusing. But
yeah. Great. So thank you for the precision, Simon. And what I propose then is to start right now with Carmen's question related to BGP Flowspec. So Carmen, the floor is yours. And of course, are you ready, Xaba?
Sure.
Right. So Carmen, you can start.
Well, it's difficult to start because I have no idea about what is this Flowspec. I've never heard about that, and also how RARE-freeRtr is doing it.
I know what Flowspec is.
Okay, so Flowspec is basically about to propagate a QoS policy network, right? And for your special case, Carmen, I think it is not suitable because you want to deal with the layer 2 session right now, and layer 2 packets are not mentioned even in the Flowspec RFC because they are about how a packet who get routed somewhere, then we have to do some extra work if it patches on a Flowspec rule. But there is just a draft right now about Flowspec layer 2, and it is basically still not about bridging, but about VPNs or EVPN. But in your case, you have only a single bridge domain, and basically no VPNs nor EVPN is present in that scenario. So basically, I think that's all about Flowspec.
Yes, but now if I want to create these counters that you told me, where I need to add this functionality. I mean, if I want to contribute.
I think for just to have the counters, you really don't need to enable Flowspec at all. What you only need is basically have the bridging in your data plane, and afterward you can apply the ACLs to count the traffic, the specific traffic you want. But before starting this topic, I was thinking further what I saw on your current drawing, and that BGP session indicates me that it will be a heartbeat. So I think they will have a different link without the wedge in the pass, and they will track if the traffic, at least the BGP, could go through the wedge, and in the case if the wedge fails, basically then the BGP will go down and they will fail over to for example, you said that we will be surrounded by Juniper, so I think they will have a logical tunnel between the two BRFs in parallel with the wedge, and in that case they will cut through. So that's why I still propose you to ask your supervisor if you can participate in that BGP. That would make your basically your whole life easier if they consider the wedge as a routing device and not just as a switch.
Okay, I will tell you something. I'm going to talk with Eduardo and then about let's see about this BGP participation that you are talking about.
Okay. So, but let's assume that we cannot participate in that BGP heartbeat thing. Then, then the thing is that we have to provide a layer 2, and that layer 2 we basically can only do bridging and bridging ACLs and basically nothing else. So no routing, nor Flowspec, nor any fancy stuff that we could do if we do routing. Layer 2 is not a too nice thing after all. Anyway, yeah, so I think the one way is the access list counters. The other thing is the QoS access list counters. That's the two things that we can do. And basically we have nothing else at layer 2.
Well, let's see, but the idea is to abstract completely from layer 3 and just use this layer 2 and bridging, but count the packets with the flow label, and with the access leads is possible. So
yes, absolutely, it's doable.
At the first side, it's enough.
It's absolutely doable. So you can do the bridging. I think it's already there, but not in the current profile that the lab is running on. And also the counting on the bridging is also there. Basically, you can use the same access list match stanzas, and you can also match on the Flowspec masks on the bridge port. it's so doable. Yes. But as I mentioned before, the current lab profile do not have bridging. So this is the thing that also Frederick and Xavier are playing right now with.
So Carmen, Does it answer your question, or maybe you would like to take this offline in a separate meeting so we can understand the need instead of anticipating the solution? That
for now is right. It's okay.
because I'm not sure about the Flowspec the Flowspec topic in your case, so that's why I guess that's a separate VC dedicated to that, and to better understand what you want to achieve, your needs, and we will see the possibilities that we can have and how you can measure this with the existing counters. Sounds right for you, Xaba, also?
Sure.
Perfect. Carmen, is it okay?
Thank you, Saba.
So that's okay for you, Carmen, also? We can. Yes.
Let me tell you some final words about this Flowspec stuff. So basically, it's absolutely not a black magic. Imagine that you have a router and you configured it as a Flowspec receiver. Then basically do nothing but opens a new BGP AFI address family toward root effectors and receives the roots basically. And here the roots are QoS rules after all. So what you got is basically a match stanza and some QoS rate limiting rules that, okay, if the traffic match, then you have to rate limit to this. And since it comes from the BGP root reflectors mainly, it is best used to when you detect that, okay, we had a DDoS from somewhere, then you can instruct the whole network at the same time to drop all the affecting traffic, and you have to configure this at only one place where you originate the Flowspec rules, and all your network devices will drop the affected traffic right when it enters your network. Basically, that's all about Flowspec, and basically it could be used if you set high enough rate limiters. It could be used to count, obviously, but again, it only affects routed traffic, and it is not about switched traffic.
Okay, thank you, Xaba. Carmen, before getting further, Xaba provided a good explanation, but the first thing to understand, are you familiar with BGP?
Yes, I study at the university BGP.
So great. So basically, you are familiar
But
also with
a
BGP root reflection.
A few years ago.
Yes, but you are familiar with BGP root reflection.
Yes.
So it means that when you have a root reflection in place with root reflector in the domain, whether you have one router or 1,000 router in your domain, it will be the same because all the 1,000 router will get reflected routes from the root reflector. Is it correct?
Yes.
Okay. So Carmen, is it okay for you for assuming that point, the first point?
Yes.
So with BGP Flowspec, it's the same thing. Instead of the address and another specific address family that would provide you the list of the route with a small granularity, with the granularity of a sniping of a sniper, which means that you can have the flow specification propagated by BGP, and then on the entire domain, you would be able to do some action. You can rate limit, you can drop the route. And this is the way I think, is used by most operators to do, for example, DDoS mitigation by mitigating flows indicated by BGP at the entire level. And then if you understand this, I guess that what Xaba wanted to mention is that in this sense, having a layer 2 domain with MAC address, BGP Flowspec won't have any effect because it is active on a layer 3 and above layer 4. And this is why I think there is a I had some confusion in understanding the BGP flow spec with the relation with the bridge stuff. So maybe we can understand better your needs by having this separate VC.
To be honest, I saw a drawing from Carmen, I think on Monday, and there was a BGP session through the bridge we should provide, and I think they draw that there because they want to do some keep alive through the bridge to be sure that we are not blackholing. I mean, the wedge not blackholing the traffic, and here came the idea that okay, if there is that BGP keep alive, basically then why don't we participate also? It won't ruin the, I mean, it won't ruin at all the BGP keep alive, because if the wedge crashes, then the BGP will most probably go down on both sides, and so they still can use it to monitor if the wedge is working or not. But if we could reach that point that they consider the wedges as a router, I mean, at least to have a default from the one side and advertise the servers from the other side, then it's from our point of view, then it's a routing device, and then from that point, basically we can do all the tricks that we practiced beforehand, all the ISI stuff without the need to deal with the same address on the two sides, and even the PBR stuff. Basically, we can do from that point much more than just on a single layer 2. But again, just to count, the single layer 2 is also okay. But basically, then we cannot do anything else. Just filter or count.
Well, count is the main goal, but I'm going to study this Flowspec and also talk with Eduardo, and I will tell you something.
Okay, no problem. So we can have this separate VC, take this offline in order to better understand what you want to achieve, your needs, and then I guess we can elaborate on what is available and what is, I would say, the best available technology, because that is suitable for you. I'm confident there are a lot of things, but
I think obviously the layer 3 will be the best solution, because if we could go layer 3, then basically we can also do the thing that we did with the policy routing. That is, we can have then more VLANs between the wedge and the Junos, and we can have all these monitored by a BGP session between the wedge and between the Junos, and then basically we can split the traffic toward the receiving side of. I mean, if we have 3 VLANs, then we can split the traffic to the 3 ports. And then you can count even on the wedge, even on your Junos, basically everywhere on the network, and not just on the access lists from the wedge.
Yes, but you need to know the next hop in layer 3.
Yes, obviously we have to know the next hop, but we otherwise. So if we move to layer 3 and we participate BGP with Junos, then we otherwise have to know the IP address of the Junoses, because we have to configure a BGP toward them. So at that point they will tell us that okay, we should point the BGP to this IP, and we also point the PBR rules to that IP. I mean. The BGP session and the PBR next hop will be the same, obviously.
But with layer 2, you don't need the next hop, so it's completely abstract in the network.
It's true. So if we only do layer 2, then basically one can simply plug off the wedge from the network, and the whole wedge could be replaced with a single deck. It's absolutely true. But then we only can count on the access lists. I mean the hit counts on the access lists, and we can do nothing more, I think.
Okay, so I propose to to postpone this topic and have a separate VC related to that. And after your homework, Carmen, and when you're ready, we can tackle this again if you're okay.
Perfect. Thanks.
So now let's talk about multipath Polka. Christina.
Yes, first of all, I would like to thank Sam for his amazing work. We have just talked a few days ago, and now Polka is ready in VC-Minar. So it's really amazing. Thank you, Xaba. We have it's very nice to see this idea in action in VC-Minar. So we started to play with the emulator and to understand how it's working. I have just sent an email, so we are trying to reproduce that that emulated RARE topology from Everson's test. We got something wrong there. We still have to debug, but our idea is to just reproduce that test case that we were exploring before with Polka, either the short or the longest path, and now we are going to send the traffic for to both paths. And then our idea was to reproduce the tests from that Polka's paper, just to check if we can do everything we were planning. But I imagine from what we have seen until now that there is no problem, because the way that Xaba is representing the multipath tree, it's quite flexible. We can just represent the individual links between each node, and so we can build any arbitrary tree. So I imagine we'll not have any problem with the representation. The only thing that Xaba pointed is that in the paper we were using nodes with a small number of ports, and if we have more than 16 ports and we are using CRC 16, we would have a problem. So this is one point that we were discussing in the email thread. So I think the basic implementation of Polka, it's already up and running thanks to Xaba.
To be honest, I won't abandon the idea and I will push it further. I mean, to implement fully that if a node have more than the variable neighbors, then handle it correctly when I calculate the root ID on the head end. Currently, the data plane part is ready, so we have the regular add, delete, and modify keywords for the Polka polynomial. That is one, so the data planes already can handle the multiple node IDs correctly. Only the head-end calculation needs to be done right now. I am thinking that how would it be elegant to introduce it. I won't abandon this idea simply because my own network also have the needs to to handle this, because my biggest VPN concentrator already have more neighbors than I can express. Anyway, if I read briefly your mail and saw that you had some issues. If Emerson is here, then I think we could discuss that what you are facing and how we can help you, if you wish.
Yes, I don't have the topology now. Emerson, could you please share the screen about the experiment we were discussing before the meeting?
Okay. I don't want to share my screen. I couldn't. I'm sorry.
Frederick, could you please make a version a host? I think it is needed.
The share screen is disabled.
Okay, so let me try to see if I can do that because I'm not super. I'm not sure how to do that in Zoom. Simon, do you have an idea?
The message is starting host disabled participant screen share.
I am not a moderator, but if I were, I guess I could grant rights to Everson. But who is the moderator anyway? Maybe none of us?
Maybe none of us, yes. This is why,
That's bad.
This is why, Luis? Luis, are you here?
Yeah, that's unfortunate.
Hello, I was in the next room listening to you.
Sorry, Luis.
I'm here running. No problem. Tell me.
I think that Everson needs the right to share his screen, and I'm not sure how to do that, and I'm not sure if I have the rights to do that. That's why.
Yeah, you should be able, but just let me. You can co-host, and now he should be able to. Okay.
Thank you, Luis.
You're welcome. The topology is running, is working. All routers, and here the.
Okay, wait a bit. What is that all zeros prefix with /32?
What route?
Okay, the index one is all zeros prefix, which is quite interesting.
In router view, the index is 11.
Yes, here, but on the index one, I saw that there is an all zeros prefix.
Index one, it's in the Amsterdam.
Here, right here. On another router, I saw that index one is all zeros somehow.
The POLKA enable index one.
Okay, and let's see the loopback. Okay. Can you go to another router, please? Right here, can you spot the index one? It is right here, not connected, and it tells us that prefix is all 0.
Yeah, it's false.
Okay, who is that guy who have the peers 2, 4, 9, and 11? It is
9 is a TCD router.
Okay, but who is that owns that all zeros prefix? That is what we should find out, I think, first.
So it's
okay, it's connected. Can you issue a show IPv4 route here? Please show IPv4 route v1. I'm interested if it's really in the table.
IPv4, sorry.
Route v1. Okay, that crazy loopback here is connected on template. I see what's going on. Okay, so the template basically don't have an address, and it should be put it should be put to shut down, not to advertise this bogus prefix. So if you could please shut down all the templates everywhere, I think it will make this crazy prefix go away.
Template, it's a problem.
Please put it to shut down everywhere. I mean, all the template interfaces on all your routers, please shut down them, and then this all 0 prefix will go away. Simply shut down. Okay, and if you could verify show IP for route P1, then it will point to somewhere else, I think. Okay, I mean show IP for route V1. Okay, and if you see now it's an OSPF route, and beforehand it was connected on the template. So so if you shut down all the templates, then this prefix will go away completely. And I think this all zeros prefix is here. You did it already. No,
template,
please don't.
Template.
The template interface, and not here, but on all the other routers.
Question, Xaba.
Yes.
Would interface template be forced to shut, or is there some reason to no shut at some point in some occasion? It's a question.
It's a regular interface, so basically you can apply an address to it, and so basically that's why it is a good idea to shut down the template. Otherwise, it will advertise the dummy address.
Ah, you mean that, for example, if I create an interface Ethernet 2, I can also in Ethernet 20 apply the command template Ethernet 2. Yes, that's right.
Basically, right now it's on the screen. So you have a loopback and 2 Ethernets, and all inherit the configs of the template.
Yeah, but the question was, for example, if Ethernet 20 can inherit from use Ethernet 2 as template.
Right now, not. Only from the template interface.
Okay,
I mean, the config could be inherited right now only from the template interface and not from another Ethernet interface.
Sure, but so the question is, shouldn't it be more safer to put the shutdown state to a template interface?
I think yes.
Okay.
The shutdown to the template is always a good idea. Otherwise, it will bring up the routing stuff, or at least it will try to do it.
So basically, Eversen, you go in each router from your lab, conft interface temp1 shutdown. Int
Interface template
temp 1 enter
shut down.
Yes.
Yes.
So now do for every single router in your lab.
Yes. Basically, that's it.
So it is for out.
Okay, now it's pointing to somewhere else. So this router is down now. With that beforehand it was connected on the template. Now it's from the OSPF. So this router is down. Please continue to the other routers and shut down all the templates.
Okay. Other template is Amsterdam. Shut down.
Exactly. Okay, still there somewhere. Okay, maybe it's an external route now, so I think it's much better. Can you check this SR index on another router just to see the index one?
Index 1 is here. Index 1 is a
Okay, but it's local, I think, to Amsterdam, isn't it? Yes, it is. Yes, it is here. Please, could you check on TCD, for example, the SR index? Okay, it's 9. And could you please check the show IP for SR index V1, just to see if the ugly prefix is gone? Okay, it's much nicer now. Okay, then could you show me, please, the tunnel head end? I mean, where you try to configure the pass. Okay, so you want to go to 1 and then to 2 and 4. Okay, here you would like to replicate, I mean, at the first hop at point 1, you replicate the packet to point 2 and to point 4. On point 2, you consider it local, I mean to local routing. At point 4, sorry, at point 3, you put the traffic back to point 2, and on point 4, you also put the traffic back to point 3.
correct.
So could you show the topology? Then it's easier to see the.
Yes, yes. Could you please show the topology?
Just a moment.
I can send the link here. Just a minute. I think it's easier.
Yes, I think it was in the mail that you sent, Christina. Let me quickly find it and bounce to the chat.
Yeah, it's good that we can see it at the same time.
I remember that I saw the topology somewhere.
It's basically the GMP4 lab.
Yeah, we are emulating it.
Okay, here is the topology. Yeah, thanks a lot. Okay. So let's see what we've got. Okay, so we are
The edge point is Rio, and
okay, so we are at Rio. Wait a bit, we are at Rio, and now we send it to Amsterdam. I think it is correct. Amsterdam will replicate to point 2, which is Frankfurt, and replicate to Poznan, which is 4. Okay, the first 3 IPs seems reasonable. Okay, point 2, which is Frankfurt, will simply route it. Okay, let's assume that it is correct. If you want to terminate the tunnel at Frankfurt, is it correct that you want to terminate at Frankfurt, or you would like to put it to Geneva? Emerson?
Frankfurt is the last core node, and then Geneva is the end of the tunnel.
Okay, then I think that point 2 should simply put to point 7. I think. Otherwise, it will be raw IP between Frankfurt and Geneva. And you will need to instruct Geneva to decapsulate if Geneva is the end of the tunnel.
Understood. Because when we were using Polka, we didn't need to include the endpoint of the tunnel.
Ah, okay. Right now with Polka, I think you should. Otherwise, it will be raw IP between the last hop. So with this current config, you will decapsulate at Frankfurt and not at Geneva.
Ok, understood. So, Everson, a gente vai precisar adicionar o Geneva ali no final do túnel. A gente vai precisar editar o arquivo.
Tá. Vou fazer aqui.
E antes ali em 20.20.2, não, ele não termina nele mesmo, ele termina em 20.20.7. Isso aí.
Aqui? Here?
Uhum. Não, mais para o lado. 20.20.2, lá, pode ir para a direita, direita. Outro lado. Isso, aí. 20.27. Is it right, Sabo? So here, Frankfurt points to Geneva.
I think it is it. It is it. And please tunnel mode Polka again. Wait. Tunnel mode Polka again.
Okay. Oh, sorry.
Tunnel mode Polka again to instruct it to recalculate everything. Okay. And could you please show Polka root ID tunnel one? And let's verify if it is what we wanted. Tunnel one. Okay, so for node 1, which is Amsterdam, we encoded 2 bits, basically bit 1 and 6 is 4 plus 2, bit 1 and bit 2. Okay, basically it's a split point. Good. All the rest, who decoded fine, is a single bit. And the only endpoint where the bit 0 is set is node 7. Node 7 is Geneva. Okay. Okay, could you show me please the Geneva part? I mean, okay, and the tunnel, please. Okay. Yes, I think it's the same. So Amsterdam should pass the traffic to point 11, and point 11 should be encapsulated.
I think it is wrong. It is wrong.
Yes. So point 1 should send to point 11, and point 11 should send to point 11, basically.
Yes. Everson, a gente tem que incluir o Rio ali naquela configuração. So it's 20. No, it's one that it's one, Everson, but then it's 1 and 11. 1, 11. Yes, then Then it's true. It's right. This one.
Yeah, I think two is right. 2 to 1 is correct,
Yeah.
and append 11 to 11, and I think it is.
So it's 2 and 1 in this part.
Yes,
Two.
that is 2.
Yeah.
Yes.
And now you add another one. Point V. Yeah. 2, 2020, 11, 11.
Okay.
Yeah.
I think it is good.
Yeah.
And
then the return path,
again, please.
Yeah, and the return path is just this single path.
Yes, I see. Okay, and could you please go back to the head end? I mean, where we want to split, and that's first. Could you please show POLKA? Yes, show POLKA root ID tunnel 1 to see how it encoded. Tunnel 1. Okay, basically it seems okay. So we got 3 nodes and 11 is decoding. I think it is it. Let's send some pings maybe.
Great, it's working. It was not working before.
Yeah.
Okay, and could you press the Ctrl+C and wait a bit? We already got 100%.
It's right because it's the single path. Now, if we ping from real, it's using 2 paths.
Okay, then let's see the 2 paths. I'm interested if you got the replicate working finally.
Now it must be 200%.
Let's see.
Yeah.
Nice.
So it was our mistake. We didn't know we had to include the endpoint of the tunnel.
Yes, right now you have to include, because basically you can have more endpoints also. I mean, so you can encode a path that not reaches a single endpoint, but you can do a real multicast replication, as I said you.
Yeah, it makes sense.
I mean, if you have more nodes, or you want to, for example, for your use case with the smooth roaming between the access points that you described in your paper, for this you also need 2 different endpoints on the tunnel.
Yeah, it really makes sense. It was our mistake. But then I think everything else, it's very simple to the way you implement it. We just need to change from POLKA to POLKA, and then to describe the tunnel in a different way because we were representing the trees.
Yes.
Okay, thanks, Gustavo.
Thank you very much.
You are welcome.
So this is nice. Just out of curiosity, so the replication is done by the P4 data plane?
Right now, I think.
Oh, sorry. Okay.
Right now we are dealing with the software application, but the thing is that the DPDK code is already there, which can replicate, and I just finished the identity-based firewall, and afterward I will progress with the Toshio.
Okay, no stress.
I think it will be sooner or later. It will be here in the Toshio.
Cool, exciting. Thanks.
And as we are emulating a similar topology to the RARE topology, we could do exactly the same.
Yes, you are right.
That's a pity because you will have nothing to do during the hackathons. You will have just to drink some
Saba's
beer
fault.
instead,
As usual.
as usual. Anyway, that was a great breakthrough. If you noticed, we have published the latest metrics, and this POLKA is inside the latest metrics, feature metrics. So you can check out also the test case there. Anyway, you have already done it, which is great. We have 7 minutes, and I'm not sure, maybe Moses, you wanted to talk about something?
Not really. I think Xaba could explain the modifications he has made to accommodate the proposal of pushing forward cloud-based NRAN for solving the inclusion of Cape Verde in the NRAN world, actually. So go ahead, Saba, and tell us the news developed during the weekend, by the way.
Okay, so the thing I did for this is basically an identity-based firewall, because the SAS, or how to say it, CISA thing converted here to something that Cisco already calls TrustSec. And basically it's about an end-to-end solution for an SD-WAN, including the firewalling, obviously in the cloud or on premises, it's up to the configuration. And for this to happen, one have to provide something called NG firewalls, and it starts with this identity thing. And the Cisco solution, and basically that also followed by. So I found the traces on the Juniper and on Palo Alto sites for this security tagging. So basically that's what I implemented. Let me share my screen, and let me show you some real quick thing about it. I think I am sharing the screen. Let's start the router.
Let me just give this Simon the context here. We are planning to submit the proposal for the innovation call from John, and trying to push forward this idea. And Saba is
Excellent. So
moving
deadline
ahead
next
of
Monday.
us. Yeah, true.
That's
That's
good.
true.
Cool.
Okay, so the basic idea behind this this end-to-end marking of traffic with an additional thing is about roles. And you mentioned eduroam. Basically, eduroam already uses .1x, which already provides a user identity. And I think it is easily can handle some more attributes in radius and propagate it toward toward the access points. And the thing is that access points are quite first-class citizens in FreeRtr. First of all, let me share my Wi-Fi implementation with you. Okay, so I have some bridges, obviously. These bridges are basically, okay, so this bridges contains a hairpin to put routing on it, but it has some channels. And this channel interface is pointing toward my access points. For example, this one is basically a part of a bridge group, and it's a TNAM or GRE. The counterpart of the access point here is, for example, this guy. And here I am implementing a GRE-TAP interface. It is the OpenVRT counterpart of it. Then basically, if I show the bridging on the access point, then every single SSID basically bridged to this to a different GRE tunnel. And this is how I can grab the traffic. And these access points are these OpenVRT access points are quite easily configurable with .1x. Back in the time, I tried especially at Rome, and back in the time at that time, OpenVRT quite easily handled the at-Rome identification. Basically, from OpenVRT's point of view, it's just relaying the radius packets into .1x, and finally, when an access accept arrives, then it just have to pick the key from it and install it to the radio, and basically that's all. And at that point, it can relay back the ELPOL packet to FreeRtr to have the identity finally. And from that point, basically we have the identity. But then we have to propagate these identities through the network. And this is where this new addition comes in play. Let me show you. So now I am pinging this this newly started seed router, which is here. Basically, it is the loopback that I am pinging right now. Here is the connected interface, and I think it is already in the template one, obviously. Okay, so I already enabled this. Or didn't I? What? Okay, but then where? Okay, it must be in the template. Okay, it is Ethernet one. Okay, so I enabled it on the Ethernet one and not on the template. Okay, so then now let's assume that this interface have the tagging enabled, and now let's forbid inward direction the 123 tag. I think the ping is still working, which is very good. And now let's tag my computer with the 1234 tag. I think it is SDN 999. Yes. As assign first, let's assign 1234. I think it didn't change the ping. It's still working. But now let's change it to tag 1234, and it stopped working. Okay, now let's allow in 1234, and basically the ping immediately starts. My bad. Okay, and basically the network pass between these two nodes was an MPLS pass, and included a lot of nodes. And basically, I only propagated this, so I only configured this SGT tagging on my notebook, how my packets are sent over the network from my notebook, and it changed the behavior on the ping. Okay, now let's do the reverse. Basically, it is 1234. Okay, so I unappended the 4 and it stopped working. And now here, let's remove this configuration, and then it works again. So basically, it's all about that when the user associates to an OpenVRT access point, then he can get the final result of the authentication from OpenVRT with ELPOL through these tunnels that I showed you beforehand. then we can assign the tag automatically to these tunnels, and then we can have we can set the user identity right when we get the frames from the access point, and we can propagate this information through the network up to the remote end. When we could filter by this information, we can consider this information also, not just the pure IPs and ports and so on, but also the identity of who is sending this packet. And basically that's what I I did during the weekend.
That's great. That's great.
I think all the rest that you mentioned, Diomir, I mean, so we have the dynamic metrics that we discussed beforehand. That is about the SD1 and how to gain some time and how to outperform ClearNet. Let me quickly show you. I have a node at Germany, and in ClearNet it shows me about in average 45 milliseconds. But if I go within my VPN trials, then it basically halves the time, simply because if I go through the ClearNet, then it usually takes crazy passes, especially when you cross multiple countries. Okay, Frankfurt seems reasonable, but maybe then the traffic somewhere diverted in between them. But if I trace through to my sorry, but if I trace through to my internal pass, then first it goes to this P4deb, which is an intermediate hop, but from here it is in the Hungarian engine, basically this VPN concentrator, and it just reroutes the traffic, and from here seemingly I have a better pass. Let me quickly show you the shows for it. Okay, so here are the measurements of the previous some measurement rounds, and basically these numbers get then averaged and did some calculation on them, and afterward basically the final result, I think, which is this number, the final result is when it changed, then it feed back to the IGP. And basically then OSPF, ISIS, and our own link state routing protocol can consider basically the link delay as a metric, and it's dynamic. So when a link changes here, then it will reroute the traffic automatically to the better performing pass, even with more hops on it. And basically that's how I gained that 20 seconds toward within my VPN.
Yeah, that would be great for the core, you see.
Yes, but it's also
that solution for the edge and for the core as well, because the core will be interconnected by VPNs.
I think it is good everywhere. So the more connections, the more measurements, and the better results, I think. So it performs best when you could implement the full mesh. Then all the VPN links could be measured, and then really the best path could be found.
Sure. Basically, because we are working not on physical network themselves, we are working on an overlay network, and that will be essential for us to find good path through the network. So great job. But can I try to summarize the achievements then? And you tell me that if I'm right or wrong. Basically, we can have simple access points. We just need to be open WRT, open WRT, yeah, exactly. Compatible. We don't need to be kind of radios compatible access points, because you are breaching all the traffic. So
exactly.
Then we'll be less expensive to set up a physical access point using EduROM. And also we can do our multi-homing connection to virtual gateways on the cloud by using this latency cost indicator, so that routing can use this thing to optimize the route to the destination.
Exactly. Let me show you here. Here is a good example. This neighbor is basically connected on two interfaces, and you can spot 2 milliseconds between the two. Let me show you real quick the two tunnels. The only difference is one is over IPv6 and the other is over IPv4. And basically, it's the same neighbor. And obviously, if I am seeking that this traffic is going to the better or the worst path, then we will see that hopefully it will go on the better path. I think it is including interface. Okay, that is sending on tunnel 19, which had the lowest metric, the lower metric from the two. So basically, it simply selected the better path, and this is you can do basically the same. I mean, multi-homing to the same POP over the two protocols, and and if you have more POPs, then you will need 4 tunnels, and it will and that it selected the best path from the 4 available.
Okay, and the killer question is, can we do our tunnels with Polka?
Yes, obviously, yes, you can.
Okay, and we can use this policy based routing on Polka using this latency thing?
Yes, you can. Basically, all the features on the TPDK data plane is available, even mPolka too, if you want to replicate the traffic.
Okay, that's fantastic. Thank you. Thanks a lot. So that's my point, and we should propose something very basic as a showcase to convince people that that kind of service is worth having and run, although you don't need the physical connection. At the moment, we can provide wonderful services using VPNs across regular broadband providers. That's my point. And the cloud providers. For the moment, we have a private cloud here in Brazil that we can make available for the project. And if you guys can find anywhere we can have a second gateway to provide this multi-homing connection, that would be great. If not, we should put aside money for public cloud providers so that we can have it on Amazon and somewhere else. So that's my point. I close my talk here.
I think the more POPs, the better. I think here we at Kifu, we also can offer a POP that you can connect if it games. I think it is not a big deal to spin up a virtual machine here. but from the east side of Europe, I bet we won't have too nice RTT.
That will be great for testing, at least. You see.
Okay then, and even we can offer BGP from this point. I mean, we already have a virtual POP in our cloud, and I think that the routers can accept the trans from Africa.
Thanks a lot.
Technically, Moses, for example, we can imagine that each NRAN in each region can provide this type of gateways, and depending on your location, it will result in a specific local region. So that's that. Yeah.
So RTT wise, I think the best location in Europe should be Portugal, right? And when I followed the inauguration of the Bellalink cable or the Ella cable, I noticed that the Portuguese landing station, it is in Sines, it's a town called Sines, and that town has a huge project for like data center to become a mega data center location for Europe, which I found interesting. So I would be curious as to whether FCCN or Portuguese NREN have any plans to have infrastructure there. I don't know. I never heard about them in the context of like community cloud. I know other countries like Italy or Hungary or also Switzerland have such resources, but it will be interesting to find out whether they exist in Portugal. But I don't have any connections there.
Okay.
Sure. But my problem is that we have to submit the proposal by Friday for the guys in HINET to help us with the bureaucracy. So what I have in hand is just this RMP POP cloud that we manage. So that's why we can offer that. So if you guys find another one that we can use for free or for a low bill or something like that, we can provide in the project. So let us know, please.
Okay, I think again we here from Hungary we can provide the POP, but I think you will better RTT. So I think we won't have that many traffic as you, simply because my best bet is that you will have the better connections, not us. We are really at the edge of the European Union here, so
Still Central Europe.
Yes, it's called Central Europe, but it's the edge. I think only Romanian is.
But I guess for a start, it's under the time pressure. It will be could be a nice solution if there's not too much bureaucracy.
Basically, I am 20 milliseconds from Germany, and the Germany is a well-connected country here. So,
but they don't do cloud. I think. In that sense, yeah. Anyway.
Sorry, Simon. I saw your hand was raised for some time. So maybe
yeah, but
you
we're already over time. No, yeah, just a small update about the hackathon.
So please go ahead.
Yeah, we're continuing to plan for presence of RARE-freeRtr at the hackathon in Vienna at IDF 113, which will be in like 3.5 weeks from now. I saw that we have the first registered remote participant, Tim Chown, and yeah, if you consider working on the weekend, then you're all welcome to register for the hackathon. So you can register for the entire ITF, that costs money, but you can also register for just the hackathon, that's free. And you can also just come to the hackathon without registering, but it will be nice to have a bit more visibility. And among the things so we have a list of projects. I think that looks good and attractive and comprehensive, but we can still modify that. It's on the hackathon wiki. So I don't think we'll have the problem that there's no work left. If Java can hold himself back a little for the next few weeks and not solve all the problems. And the last thing I stupidly suggested was that we could bring some merchandise to the location and maybe also send it to remote participants, such as mugs or stickers or maybe t-shirts. I don't think that exists for RARE-freeRtr, but maybe it could be done with the help of the project. Maybe we won't be able to get it done in 4 weeks, but maybe for another time. So if people have ideas for designs or something, personally, we got a bit of feedback from someone in Géant, like PR, who noticed that when he looked at the RARE web pages, he said, yes, this looks like 1995 websites. And I thought to myself, well, this is maybe not bad. It could be a nice t-shirt design based on just screen dumps of the wonderful cursor-based tools that Java is using. And it could be green phosphor green on black to make it a bit retro. I think that would be popular with the people in the ITF crowd, I guess. And then, I don't know, have a display showing off how many mega packets per second you can transfer with a $200 router with FreeRtr or something. So if people have ideas, will be an opportunity to discuss them in the preparation of this hackathon. Yeah, and otherwise, I'd be curious as to who would be willing to participate and hack with us for those 2 days mainly. So Saturday and Sunday, I think it's 19th and 20th of March, or 18th, 19th, not sure. If we have a significant remote population, then we should think about how we can communicate and work together with some people on site. At least Java and me will be there, and maybe we can find someone from the people who are in Vienna and the people who would like to do some work from home or from the office. So the IETF has a facility called Gather. It's on the internet on gather.town. It's like a 2D virtual environment that looks a bit like a meeting venue. And in there you have a room on for the hackathon with some tables. So maybe this is something that we could try before the real hackathon, whether we can use that to participate between local or on-site and remote participants during the hackathon, so that people can just ask questions and help each other as if we were in one room. So maybe this is something to try on the next on one of these meetings here, maybe next week or something, if you're willing. There is a URL, so the rooms have been prepared for the next meeting, so we can try it in a natural setting. It would just not be on Zoom, so we would miss it from the recording, I guess, unless one of us does a screen share of the Gather interface into Zoom, but that can become tricky if multiple people are on both systems. But I think it's something we should try beforehand. And I see positive feedback from Christina and Carmen, who would like to participate remotely. That's absolutely awesome. Cool. Yeah. Okay, good. I guess I post the links somewhere. Maybe I did post them but probably to the wrong list. So if people would like to know how to access this Gather site and haven't seen my messages, which might have been on the work package 61 list rather than the rare list, then please let me know. I'm not sure where I sent them. Okay, that's all I have. So, and as I said, we are officially part of the hackathon now. There's some descriptions of tasks that we can still work on. I have volunteered Java and myself to be available for the entire time of the hackathon if people have questions and need a contact. So yeah, let's see how that goes. But so the schedule is, it starts pretty early, something like 9:30 or so on Saturday, and on Saturday it will go until 9 p.m. local time. So like even for people on the other side of the Atlantic, it should be possible to work like until the afternoon. And on Sunday it's a bit shorter. It's from 9 to I think 4 p.m. local time, and they have to give up the room for something else. And then on Monday, at a time that I don't know yet, there will be the so-called Hackathon Happy Hour, where the participating projects can present their results. And I think we should also present there, but I don't know when it is. and it will be something like a 5-minute presentation or something of the stuff that we worked on. So you have to prepare a couple of slides, and then we get some visibility in this ITF crowd. Yeah, so looking forward to hacking with you people, or like at least facilitating the hackathon. Thanks.
So thank you, Simon, for this precision. So I'm sorry to say this to you, Everson, but you know what you will have to do during this weekend. I'm kidding. But never mind. We will figure out. So I hope that you will all try to make to be available during this hackathon. That will be a great, I would say, event. And obviously we will have to check and to agree on some task to tackle during this weekend. But I'm pretty sure that considering the list that have been prepared by Simon, we'll have something interesting to do.
Yeah, and I guess you could also just go around at the hackathon and see what the other teams work on. Like probably Java will find a new protocols that are still like undiscovered, and maybe also talk to people and try to set up some interop tests and so on. I guess I'm pretty sure we won't run out of ideas. Yeah.
That's perfect. So Christina, from the time being, you must not tell something to Xaba, because otherwise he will try to implement it before this event.
Okay, I'll be quiet.
And I guess that we can close for today. So thank you all for your availability, presence. Moses, thanks for your availability also, and this initiative, a brilliant idea. I really think that we can do something. We can make the difference in this type of project. And
good luck for the innovation program proposal.
Yeah. Good luck also.
Thanks, Simon.
Moses. But with AOIN from HANet, I guess you are in a good hand. At least it will be well formulated. So thank you all. And have a good end of the week then. Bye.
Bye.
See you all.
Thank you.
Bye-bye.